Life on Mars. Mars, a cold, rocky planet with an ultra-thin atmosphere, holds plenty of promise for our quest to become a multi-planetary species. Located 170 million kilometres or 300 million miles away from the Earth, this dynamic red planet has drawn plenty of comparisons with our planet. And you sometimes wonder what life really looks like on Mars. Well, let's find out. Named after the Roman god of war, Mars is the second smallest planet in our solar system and the fourth closest to the Sun. It is covered in soil, rock and dust that originates from iron oxide. This gives the planet's surface a predominantly red, rusty colour. Mars is blessed with two asteroid-like moons, Deimos and Phobos. Both are named after the two horses that pulled the chariots of the Roman god of war. But one of them, Phobos, is headed for destruction because it is expected to either be ripped apart by the tidal forces of Mars or alternatively crash into the planet's surface sometime between 30 million to 50 million years from now. On average, a one-way trip to Mars should last about 8 months, depending on your travelling speed and the route. That sounds like a really long trip and wouldn't really entice non-adventurous people. But guess what? You'll actually get more time on your hands if you live on Mars. Unlike the 23 hours 56 minutes we enjoy here on Earth, a day on the red planet runs for 24 hours 37 minutes. As a result, a year on Mars is 687 days long, which is almost twice the number of days in a year on Earth. The reason for this significant difference is that Mars is further away from the Sun than our planet, so it needs more time to complete a full rotation around it. Mars orbits the Sun with a speed of 18.5 miles per second, as compared to Earth, which rotates around the Sun at 14.5 miles per second. And just to mention that the Earth is about 6 times bigger than Mars. Furthermore, the red planet is about 72% denser than our planet. Similarly to Earth's axial tilt of 23.4 degrees, Mars has a tilt of 25 degrees with respect to the plane of its orbit around the Sun. What this means is that the red planet is likely to experience different climate seasons, just like we do on Earth. However, unlike Earth, Mars has a pretty weak atmosphere that contains roughly about 96% carbon dioxide and 3% nitrogen. The weak atmosphere makes it difficult for the atmosphere to trap the heat released from the Sun, which explains why the planet experiences a cold climate ranging between -100 degrees Celsius during the winter and 20 degrees Celsius in the summer. This extreme temperature threatens our proposed colonization of the Martian world. Gravity on Mars is quite different from how we know it here on Earth. The gravitational pull on Mars is around 62.5% less than what we feel here on Earth. To add to that, the ground surfaces of Mars is 62% lower than Earth's surface. This, combined with the lower amount of gravitational field, means that an average human would be able to jump 3 times higher on Mars than they would on Earth. Official fact sheet published by NASA revealed that a 100-pound load on Earth would weigh only 38 pounds in the Martian world. Mars is regarded as a terrestrial planet due to its hard and rocky surface. To the northern area of the planet, you will find flat plains. Meanwhile, on the opposite southern region, there are ridges and craters. With that said, the biggest crater on the red planet is called the Borealis Basin. It covers about 40% of the planet's entire surface, measuring over 8,000 kilometres in diameter. The surface of Mars is known to feature different channels, plains and canyons, which according to some sources are caused by water erosion wearing out the planet's surface. By scientific accounts, the largest canyon in our universe, the Valles Marineris, is domiciled in Mars. This gigantic narrow valley is about 6.4 kilometres deep while covering a distance of around 1.6 kilometres. Ultimately, this further fuels the hypothesis that water once existed as a liquid on the planet a long time ago. Liquid water is seen as one of the factors that scientists consider when they're predicting the existence of life on a planet. For all the suggestions of the possible existence of life on Mars, scientists would be glad that they have some sort of evidence to back up their claim in the form of liquid water. The reddish-coloured planet has been touted to hold water in various forms in the past. The notions were so strong that the American astronomer and mathematician Percival Lowell announced the sighting of alien-made canals on the planet. Unfortunately, Lowell's claims turned out to be a misconception that was caused by the limitations of his telescopes. But since then, many other space observatories have done on-site and report clear signs of water on Mars in different forms. In fact, the deltas and riverbanks on the Red Planet are said to have existed in abundance on the planet. So where did it all disappear to? As suggested earlier, the liquid water on Mars is believed to have existed for more than 4 billion years, about the same time that our universe was formed. Obviously, there is no digital evidence of how it came about and how it vanished. But thankfully, technology has made it possible for scientists to theoretically travel back in time to observe everything that played out. A team of geologists and atmospheric scientists recreated the conditions in the early formation years of Mars, and they found that a significant amount of its water could have been trapped together with the minerals underneath the planet's surface, where it remains at this moment. Another school of thought believes that the water evaporated into space as the planet's atmosphere was yanked off by the radiation of the Sun. But then a recently published research work suggests that both the atmospheric exodus and the geologic entrapment contributed to the disappearance of water on the planet. NASA's Curiosity rover spacecraft has been trying to unravel this mystery for a while. But while attempting to do so, it has led humanity to the discovery of another form of water in another form. Today, water is said to be present at the poles and potentially other frosty areas of the Martian planet. Mars is subjected to solar storms from time to time. In 2017, NASA's Mars Atmosphere and Volatile Evolution MAVEN spacecraft spotted a solar event on Mars that lit up the planet like a light bulb and shone 25 times brighter than any other solar event scenarios before it. Over time, these violent dust storms have continued to occur, causing changes to the planet's surface. The largest volcano in our solar system, the inactive Olympus Mons, is located on Mars. It measures 26 kilometres in height and 600 kilometres in diameter. That's around 14 times the length of the London or US Marathon. For perspective, that's about 3 times taller than Mount Everest, the supposed tallest mountain on our planet. Due to the similarities between Earth and Mars, many of which we have highlighted so far, officials at NASA and super-rich tech innovators like Elon Musk are confident that humanity will someday colonise Mars and live happily ever after there. To fulfill this goal, NASA has made huge financial commitments towards developing several space probes to explore the Martian world on our behalf. This include the Viking 1, Viking 2, Mars 2, Mars 3, Spirit, Phoenix, Pathfinder, Curiosity and the Opportunity rover. They've not been able to crack the code per se, but their findings have been very much helpful to the multiplanetary studies of scientists, and hopefully they'll find a breakthrough pretty soon.